Here's an iPhone 11 that does not turn on, and I'm going to show you the right way to diagnose no power issues on iPhones. So right now I have it on my USB meter and it's drawing 0.007 amps via USB. There's no signs of life. And this is an iPhone 11. It's in good condition. No obvious reason why it's not turning on. But don't just use the USB meter to diagnose. Next step is to open up the phone, get rid of the screen, and unplug everything. Any of these parts that are plugged in could be the reason why it's not turning on. Any of them. All of them could be the culprit. So let's get the board out of the housing and do a further inspection. Alright, so I got the motherboard out. We were isolating the issue to just the motherboard. So in physical condition, it looks clean as well. But why doesn't it turn on? So we need a DC power supply, which is this thing right here. It is set to 4.2 volts and 3 amps. Then we have a boot box. This is connects to the DC power supply, and it has on and off to connect power and disconnect, and a prompt to boot. But I'm gonna use my favorite iPhone 11 mechanic boot cable. So with the adapter for USB-C, because this one is USB-C, we now have a setup here to test the board. So why doesn't it turn on? What we're going to do is plug in this DC power supply directly to the battery connector. And then what we're going to do is we're going to push power. So right now this is depressed, so meaning the power just stops here. So that DC power supply has 4.2 volts and it stops here. As soon as I press it, it'll continue to the board. So what happens? We get a 3 amp short before prompt to boot, meaning we're getting current draw before I even tell the phone to try to turn on. So think of it like putting gas in your car and the car consuming the gas as soon as you pour it in without even turning on the car. That is not a good sign. So that's what we're seeing here. Now, what is causing this? Well, typically there's 3 lines that will short and create this symptom. 1, VDD MAIN, 2 is VDD boost, or 3, Batt VCC. So let's go take a look at ZXW. This is a board view software that allows us to see all the networks of circuits on the motherboard. So this is the layout. This motherboard is actually a sandwich board design. So there's two motherboards sandwiched together, and this is the complete thing. So we gotta first find Batt VCC. That's gonna be the battery connector. And actually this one's called a little different on this model. It's called VDD MAIN charge. So let's check it. With my multimeter in diode mode, we're going to put red on ground. And look at that, we have a main short on this line. Now this one, I believe on this model is directly connected to main. So maybe that's why. Let's go to the next line. Let's find VDD MAIN. There's a few ways to find it. One is find the PMIC, which is here. This is basically a chip that has a bunch of these coils or inductors around it. The chip is very large, and there's a bunch of caps around it. So if you click on one of those and you see it highlights the majority of the chip and majority of the board. So all that red stuff, that's going to be VDD MAIN. So on the top board, where can we find it? All right, let's measure this cap right here. So very important to always peel these off. That way you can see the board. And this board is actually here for data recovery. They need all their pictures, videos, and text. We have to fix the motherboard so that we can get the device to turn on and get the data. We cannot just pull the data out of a memory chip. We don't have a magic tool that we can just plug into and extract it. We have to fix the phone and then get it to turn on, and then we can get access to the data. So it's going to be the one right below the Apple logo, and there is underfill on it, which means it's covered up. So I gotta expose it by poking it with my tweezers. Alright, that should be enough. I went a little overkill on that, but whatever. Alright, red probe on ground. Black probe. Yep, shorted as well. Next is VDD boost. That one's a little harder to find. Luckily on this model we do have a net name, so we can just type in VDD_boost. Select it, and then where is it at? Oh, this one's inside the sandwich. Is there somewhere to measure outside the sandwich? No. So this one we have to split the sandwich to find it. So let's just skip that one for now. And we know we have a short on main. So let's see, can we spot the short without doing anything, just not splitting it? Well, we gotta use a thermal camera for the best results. This is a C Compact Pro using my custom stand and macro lens. And I'm gonna put the board under the view. I'm gonna push power and I'm gonna try to see where do I see heat. I can see heat there. All right, so let me turn it off, turn it on. Now the question is that heat under the shield or is it inside the sandwich? Let me flip the board around. So you have 3 amps flowing and nothing's heating up on the bottom side. But if I flip it over, you can see something around here is heating up. So there's 2 possibilities. All right, so yeah, so the heat was around here. So first let me pull up VDD MAIN. So let me just type it in here at the bottom. Look at that. So we see heat around here. So it could be these caps can short to ground. It could be the IC, or here's the same part of the board but the inside. So it could be this cap, it could be something around here. We kind of have to just take a guess because there's no easy way to know. See that? It's hard to tell. The nice thing about my stand is we can zoom in by lowering it, adjusting the focus on the camera. And now you can see. Also, that's another key benefit to this thermal camera is how you can raise and lower the camera, and you can adjust the focus and see how the camera like makes really clear where the short is. That's what I love about it. Right now you can't really see it because we're not looking directly at it, but once we do, I think you'll see what I mean as to why it's so good. So I'm gonna go ahead and make the executive decision to just split the sandwich so we can see where the short is. So what I'm gonna do is I'm gonna put my iPhone 11 here on this sandwich heater. We're gonna set it to 200, as you can see there, and then we're just gonna give it a few minutes to heat up so we can split it and then check again to see what's going on. All right, we're at the temperature, so this should be pretty easy to split. I like to just insert my tweezer here. There we go. Grab it, lift it up, turn on the fan, flip this over, and now put this aside. While we wait for this to cool down, let's do a visual inspection. One thing that always worries me is the PMIC. Is it cracked? No, it's good. No other chips look cracked in here. Everything looks good. The solder balls for the sandwich are also looking good. So this will make it really easy to re-sandwich after. So, like I said, the short could be one of these components, or it could be something over here. All right, so let's inspect the underside of the board. Let's do the exact same test to see if we see the direct heat here, or if it looks like it's just a generic glow, then it's gonna be on the other side. So 3, 2, 1. Oh, look at that. That's the generic. I call it like a generic glow, just a slow glow and expansion. That means I split this for nothing. So this is gonna be on the other side. But kind of good news is, in order for me to access this part of the board, it is a good idea to split these sandwiches, because if you try to do it without splitting it, you might warp the board. All right, so since it's not on the inside of the sandwich, it's gonna be under this shield. So as you can see, there's a sticker here. So let's see if I can pull this off. Now I wonder, would I have been able to see that? Let's see. Let me peel this off. Alright, there's some holes here that could kind of give us a sneak peek into what's inside. I'm just going to leave this on the board holder. Now the board Let's give it a few seconds to cool down. All right, let's turn it on. All right, the board is still kind of warm. So I'm dropping ISO to cool it down and blow it away to also cool it down. This is an experiment I'm doing in real time because I'm curious myself. Could have saved myself splitting the sandwich. So let's see. It's cooled down. You can see it's like not as bright color. Maybe. You kind of see instead that hole lights up, but that could also been, I don't know. Yeah, I think it just kind of, you have to take a guess and deal with the consequences. All right, so let's get the shield off. Problem is this thing has underfill between the actually this specific board does not seem to have that much. It kind of does. So we use 250-ish. I might not always land at 250, so just go with the flow. We're gonna remove this underfill first so that we can lift the shield without causing any damage to other stuff. 250-ish temperature is good to soften the underfill that we're picking off, but not too hot to melt anything. By the way, if you need your data recovered, send me a message for a quote. We offer mailing service to anyone in the world for data recovery. If you want to repair, we only do repairs for the US. Internet, we do some Canada, but just keep in mind Canada shipping is expensive. So, but data recovery, we're taking in jobs from many different countries. Before I wasn't doing international, but now you know, I kind of decided to give it a try, and so far so good. And links to my DC power supply, the boot cable, the boot box, everything is in the video description. Make sure you guys are checking that out. I spent a lot of time writing that thing out, going through, you know, all the different sites to link you guys to it. You know, it's not that's work as well as making the video, editing it, making the thumbnails. So I appreciate everyone who watches these videos, comments on them. Let me know in the comments what you're learning from these, what type of videos you want to see in the future. Alright, so I cleared out all that underfill. Now to make it even easier, we're going to add some flux. And then to make it even more easier, we're gonna add some I call it super low melt. Officially, I don't know what's the official name, but it's 138 Celsius solder. It makes desoldering shields super easy. So you just add it to the solder joints where you want to desolder. Now, not every solder joint is you're going to be able to reach. Like in here, there's a lot of components nearby, so just get whatever you can. Even adding it to the shield itself can help with that, although it doesn't really stick. Now this specific shield is sealed off, meaning the whole perimeter is soldered down, so there's no opening for you. So there's a few ways to tackle this. One is get a tool in one of these holes and pull up. So I'm using a hook tool, especially because I have a bunch of low melt solder here. I'm kind of focusing on that point. Also keep in mind the NAND is right next door. So if you don't have experience doing this, be careful. It is a, you know, I just had someone who destroyed their phone because they thought I made it look easy. So then, you know, they decided to try a repair themselves and destroy the phone. So this is just for entertainment purposes. Do not try this at home. There we go, the shield is off. Always look for any bumped components, any bridges, any stray solder balls. And as you can see, everything looks in perfect condition as far as the components. You cannot see which component is bad. That is very common. So you do require some way to see it, whether it's thermal camera or freeze spray or rosin. There's a few different ways. In my case, I prefer a thermal camera. Thermal camera is you pay for it once and that's it. You know, freeze spray or rosin, you have to keep rebuying it and stocking up on it. And if you run out, there's basically nothing you can do. All right, so here you go. Moment of truth. Did we find the short? I'm gonna turn it on. 3, 2, 1. Look at that. There it is. There's the shorted component. Now let's zoom in. So, like I said, this one, the stand allows you to lower the camera closer, and then you twist the lens to refocus. And then 3, 2, 1. Look at that. You can see the exact component is bad. This one right here. So you can see the chip. There's a cap here, and then you go to the left. So basically, there's a two row caps that meet, and it's that corner one. So the other thermal cameras are not this clear. See how the surrounding goes dark, and then just that cap lights up? The other ones are more like this. Like if I change the setting, like it'll glow, but it's not as good. So here, let's browse through the different settings. This is my preferred setting because it does the automatic contrast to point out the bad component. A lot of thermal cameras look like this, actually. So it's a bunch of colors, you press it, you can see something heating up, but it doesn't like pinpoint it like this one does. Right, so you can manually adjust as well, which doesn't work that well. So yeah, this setting right here on the C Compact Pro, it just comes in clutch. You can physically see which one it is. I'm actually gonna just leave this all plugged in, turn it off, and show you. Can you see why this cap is bad? No, there's nothing there, but we gotta remove it. So if we're lucky, I could stick my blade in here and twist it. Oh, look at that, it's coming off, perfect. And then I just kind of keep wiggling like a loose tooth. And it's off. Visually, there's no signs that this is bad. But, let's verify. I can prove to you that it's bad. Because this is a capacitor. There should be no continuity across it. Meaning, if I probe in diode mode, one leg to the other, we have continuity. We have 0.001. This should be OL. It should be like this, no reading, like if they're not touching. Capacitors should not do this. Pull off a known good capacitor and do this, you'll see it just stays OL forever. So this goes bye-bye. And then let's check it again. There you go, no short. I have it on, you can see the light green on or off, no current draw. Now we got to prompt the boot, which is a whole other thing we got to do. But for the sake of time, I'm going to re-sandwich this board back together. So I'm going to turn this back on to 200 and quickly add some flux. So 11s and 10s, so 10, 10S, 10S Max, 11, 11 Pro, 11 Pro Max. We are lucky that this has low melt solder, so it makes it really easy to re-sandwich. You don't have to reball it. 12 and newer, you have to reball it. Why? Because the solder is very high temp. The same temperature that everything else is the same temperature that's the sandwich. So if the heat you need to re-sandwich everything back together is this intense heat that you don't want to purposely expose the board to that much heat. But this one, the sandwich pad temperature is really low. I think it's like 148. So that will melt before anything else. So right now we're at 125, so we're getting close to the temp we need. or 150. All right, let me adjust it. I couldn't see it without the scope, so we gotta align it. Basically push the board so it's only sitting over the pads. Now make sure you guys take your repairs to professionals. If you take it to someone who doesn't know what they're doing, they could damage the board and make things way worse and end up having to basically destroying the phone, destroying access to data, and whatnot. You know, we've been doing this for many years, since 2017, micro soldering, and we would be happy to help with any board repairs or data recovery. You know, this is what we do all day, unlike other shops who do screen repairs all day and then occasionally do motherboard repairs. You know, we do this all day, so we are the masters. We have true understanding or deeper understanding of how all this works. So just careful when you are shopping around for the service. One thing about our shop is we are often the shop that other shops send their stuff to because they can't do it in-house, or they screwed it up in-house and now they need us to fix it. All right, so this is sandwiched together. I'm gonna turn on the fan and pull this down and see if it works. All right, it has cooled down. I have it connected. Now I am gonna leave that shield off. This job is just for data recovery, so we don't need to risk rooting the data by just putting on a shield that does nothing. So with that, no short before prompt to boot on the DC power supply, on or off, it's the same. This is what we want to see. Next step is to prompt to boot. To do that, we have to find the power button pin. We know the power button flex plugs in here. If you look closely at the net names, button power key con L. This line here, if you short it to ground, will trigger the power button function. Basically, I gotta short these together to trigger the prompt to boot. So I'm gonna do this off camera, but look at the DC power supply. I'm gonna touch them right now. There it goes. Prompt to boot, 78, 1 something, 87. Keep holding. And prompt to boot looks normal. So that means the phone is probably booting. Next step is let's throw it in the housing. Boot consumption tells me a lot about what's going on, and this is how you can use, this is the right way to diagnose this type of issue. So I've reassembled the phone. I have everything plugged in because it is now fixed. Take a look at this. I'm gonna plug it into charge. USB meter shows it's charging, Apple logo, and take a look at the current draw. We now have a much higher reading. Originally it was 7 milliamps, now we're at 700 milliamps, and eventually it will go above 1 amp. There you go, 1.1. Now it does take a little bit. Look at that, it unlocked when it first boots up after a long time, but you can see it's now charging properly. Actually, I see why it's not charging. It's not pulling the full amps. So the reason why it actually should be pulling like 1 or 2 amps, but it's not, because the battery is already 100%. So when the battery is fully charged, the USB meter doesn't charge properly because you don't want to be putting 2 amps into the phone when there's no room for it to go. Now if we go to general, we go to iPhone storage, we'll be able to see that there's a ton of data on here. There's 60 gigs of pictures, videos, contacts, text. The customer requested pictures, videos, and text. So we'll be able to get the customer's data. The device is stable. This is most likely fully functional as well. Yeah, turn off airplane mode. You can see no SIM. That means cellular is working, Wi-Fi, baseband, Wi-Fi, Bluetooth. So this is all good to go. We're gonna back this up, extract the customer's data, and we're good to go. So let me know down below in the comments what you guys learned from this video. I will link to all these tools in the video description. Join my locals community if you want to support the channel. Get yourself one of these t-shirts as well, another way to support the channel. And hope to see you guys in the comments. I will link to another data recovery video down below, and reach out to me if you need your data recovered. Website down below as well. So see you guys in the next one.